Hello, welcome back to the second videos of this Pocket series. On the last video we left here with the RP2040 and the voltage supply and the memory, the flash memory. What I have noticed from the schematic supply by the Raspberry is that as you can see, the chip is actually different. The layout of the chip is actually different from this one. Let's see if I can put a little bit both in the same screen. So if you see here, we haven't got many voltage pins in comparison of the chip they're using on the specification. So I think the layout of the pin supplied by the KiCad library is not quite right, and I haven't been able to find a proper a similar chip, so a similar layout. So what I'm gonna do, I am going to copy the symbol from the file that Raspberry provide, and I'm going to paste it here. So at least in this way I am sure that I have all the pins that is required. So what I'm going to do now, I'm going to delete the existing pin, and it just to rearrange a little bit this I just need to rearrange the whatever I have linked before, so I can just grab those and click them roughly. They are not much in there, so I'm gonna do SD3. I think those should match there, and I'm gonna plug that one in, and I'm going to plug that one in. So regarding about the data, they are on the other side. So what I am going to do, I am going to move this one over a little bit, and I am going to flip them like this, and now we should be able to just reconnect it. So I've got this D plus and D minus, so that's about it. Basically that's what we do, and now I can continue to connect the rest. Basically I am replicating mainly the schematic they give you actually, because it's free to download, but because I'm changing, I'm not need to pull all the pins and everything, so I just prefer to redo it from scratch and adjust anything that need to be adjusted. So let's continue. So from here, what we have on the schematic, we need to put capacitors, the coupling capacitors for each of the voltage pins. So I'm going to copy that, and we have 1 2 3 4 5 2 4 6 7 decoupling capacitors. So I'm gonna plug them in. 1 2 3 4 5 7. Okay, and we have all 100 nano. I should have changed the value before I copy and paste it, but I haven't. And those ones need to be connected. The bottom need to be connected to ground. One side to ground and one side to 3.3 volts. So we're gonna connect all these to ground first. So let's get the ground symbol and we're gonna plug that in, and then we're gonna do the same up here. The same up here, and we are using basically all these VDD pin. All this will be connected to 3.3. So I'm pulling this one up, and I'm gonna where I'm gone. I'm gonna grab my 3.3. There we go, even a little bit too high, but I'll adjust it afterwards. Then from here we'll link it to that one, and we add in another decoupling capacitors. This time is 1 microfarad. Then let's see if I clutter as little as possible. And that goes there. And then what we add in from pin 44 all those it's basically they tell you how to connect the minimal parts, so it's you just need to follow the schematics. So on here what we're going to pull from their schematics is the comment. So we know this one needs to go close to that. Also we have comments for the USB. So on here is no anymore C10 because my way to position the order I put the capacitors is different from what they have. So done that. So what we can do now, we are only left to put the crystal and another voltage for the digital, which sure if I need that. Let's have a look. Let's do the crystal first. So for the crystal, let's have a look if we can find it. So ABM8. And let's have a look if I just look for crystals. I need a 4-pin crystal. And we need the ground on 2 and 4. 4-pin crystal ground on 2 and 4. There we go, that one. So I'm using that one, and I'll select the footprint afterwards. So I turn that one around. And also I want to copy the spec. So this is a, I need to check the specs what frequencies run into. So here I need a couple more capacitors. Couple more capacitors and 1K resistors, which I can copy that one. So from here we have that connected, that connected. This one is gonna get connected up to here. This one I'm gonna get connected up to here. And we have this one connected there. This one is going there. And then we need a ground. There and there. And then we need another ground here. That goes there. Then we need to add a label, which is gonna be in. And then another one, it will be out. And for that we do the same here. So I am going to go up to there, roughly there, copy. Okay, I'm gonna connect in a second. and I'm going to this one as well. There we go. That's done. Then we just need to connect a couple of ground points here. Then let's have a look. Let's have a look what we got. Let me grab the documentation first. Let's have a look where I put them. If I put it there, that should be okay. Let's have a look at this documentation. So let's go back up. So that would be the minimal requirement, but I don't need all that. That's the power. That's all the capacitors, which is okay. 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 So it does say connecting to have a internal potential and produce a 1.1 volt supply from a meter. We simply connect the VIC out pin to the DVD pins. But where that goes. So we've done the flash. Okay, the crystal. Let's have a look. Okay, the crystal is a 12 megahertz. So let me put that one there. So I do remember. So there is no +1 out here. So this is the whole schematic they supply with you. I think after I don't have to connect this one. So I am going to close that one out, and I'll have a look at this one, because the Raspberry, you can run debugger with a SW clock, or in other ways. So I may put 3 pins here, but I'll have a look. What I need to put down is the BME 688. This is the chip I will need, and for that I need to pull up the datasheet as well, because I need to check which one is which. But I need to pull the datasheet of the BMA, because I want to see how to link it. So I'm going to use the SDA and SCL, so I'm going to use the schematic, because I'm going to use I2C, I believe. Let me check. The I2C. Pins. Okay, let me go back up and pin out. And I need to know which one is going to do the I2C. Okay, I2C 0. I can use this one, GPO 0 and GPO 1, which is going to be GPO 0, GPO 1. Here we go, those ones. So GPO 0 is SDA. So let me put a label so I don't forget. I2C SDA. And then we're going to put I2C SCL clock. One more. There we go. And if I look at the schematic of the BMC, BME, SDA is the 3rd and SCL is the 4th. So this is SDA. And then is the clock, which I tell you there. Those, they need to be connected with resistors. Normally, tell you, where does it tell you? Tell you about here, 4.7. So let's get those one and another one. I'm gonna put it here for now. I'll give a bit of a space. So this is going to be connected down here. This is going to be a little bit longer. is going to be connected there. I want to get that one. Copy and paste. Right. I can pull that one up here. Same at that one, and let me put back there. So the ground can come down. Let me have a look. For now, and I'm gonna grab that, which is gonna go up here, and it's gonna get connected to both of those, if I'm not mistaken. Yeah, and then we're gonna connect it to the VDD eventually. From here, it's gonna get there somewhere. So ground is going to ground. That is going to ground. Let's get a ground. For now, I hate when these one does like that, so I'm going to put it there. But also I need two capacitors connected to ground. So at the moment I've done this connection. I need two capacitors for ground. I get that, and I can get that there, so I can connect that one there, that one here, and what capacitors we need. 100 nanofarad. Okay, and those are connected to to 6. This one is connected to 6, and the other one connected to 8. So I'll go then 6 is connected to the VDDIO. This one is connected to that. And that one is goes there. This one is also connected to ground, because I'll get the address, default address 0 on ground. If I connect it to the VDDIO to the voltage, it's get the address 1. CSP NVIDIA is required. So I've done that. this is a 4.7k, and this is a 4.7k. Oh, point, no, dot. Okay, okay, so that's connection, and I think I can connect both on the same. That goes there. Actually, I can do like that, and I can put the 3.3 volts. So the main connection has been created. I don't need any of those other. Oh yes, I need the others for this, the LCD. So I still need to look about those. What I'm gonna do, I am going to put create those, and we're gonna call it run. SW clock and SWD. So for now, I think I'm gonna save it, and for now we'll leave it as it is, because I've done the most. I just need to look out the display and connect that, and then I'm gonna put actually, let me put 3 pins down now, because otherwise I will forget. Connector is gonna be 3-pin connector like that, and I can put them anywhere. I can put them up here. Where do I have a bit of space? I can put it here. Oh, what I can do, I can actually put it there, and connect it directly. It's not much, although yeah, that's fine. No, don't like it. I don't like it there. So what I'm gonna do, I'm gonna put them down here, and I'm gonna do as I've done with all, so I'll keep a bit of consistency. So copy, So for the value of this one, if I use the same crystal, are gonna be 15. If you using if you're using something else, you need to check the data sheet of the crystal, because it may need something else. Okay, let's save it, and we're going to do the rest on the next video. Thank you for watching, and see you next time.